Supercomputers are high-performing computers designed to tackle complex computational challenges. They encompass multiple central processing units that break down the required tasks into multiple parts and process them simultaneously, which effectively results in high-speed computation. The performance of supercomputers is measured in terms of floating-point operations per second, flops. Supercomputers can be utilized for general purposes as well as special purposes such as Bell, Hydra, and Deep Blue for playing chess. Features and working of supercomputers. Supercomputers possess multiple distinctive features that set them apart from conventional computers. These are described below. Multiple CPUs. Supercomputers incorporate more than one CPU. Each CPU contains circuits for interpreting program instructions and executing arithmetic and logic operations. Speed. These computers can support the high computation speed of CPUs. Storage. It has a very high storage capacity. Rapid retrieval of stored data and instructions is crucial to support high computational speed. Vector arithmetic. By using vector arithmetic, they can operate on pairs of lists of numbers rather than on mere pairs of numbers. Multi-users. A supercomputer allows multiple users to access supercomputing simultaneously. History of supercomputers. The trajectory of supercomputing was set in motion during the late 1950s when the U.S. government initiated consistent funding for the development of high-performance computer technology, primarily aimed towards military applications. Key events. In 1976, the Cray-1 was introduced, which was the first successful implementation of vector processing. In 1985, a 4-processor Cray-2 became the first computer to exceed 1 billion flops. Roadrunner, exceeding 1,000 T-flops or 1 petaflops, was built by IBM. Contemporary supercomputers. Currently, the IBM Summit holds the title of the world's fastest supercomputer according to the top 500 supercomputer list. Following closely is another American supercomputer, Sierra, which has a peak speed of 125 petaflops. Other significant supercomputers on the list include Sunway Tehulite in Wuxi, China, Tianhe-2 in Guangzhou, China, Dell Frontera in Austin, USA, PIZ-Daint in Lugano, Switzerland, and AI Bridging Cloud Infrastructure, ABCI, in Tokyo, Japan. The United States dominates the top 10 with 5 supercomputers, while China follows with 2. Supercomputers in India. In 1987, the USA denied India's request to purchase the Cray XMP for academic and weather forecasting purposes, which compelled India to promote its supercomputing program. Agencies involved: Center for Development of Advanced Computing, CDAC, Center for Development of Telematics, CDOT, National Aerospace Laboratories, NAL, Babha Atomic Research Center, BARC, and Advanced Numerical Research and Analysis Group, ANURAG, took the lead in this direction. CDOT developed CHIPS, a high-performance parallel processing system. BARC created the Anupam series of supercomputers. ANURAG created the PACE series of supercomputers. Puram series. Puram supercomputers are designed and assembled by the Center for Development of Advanced Computing, CDAC, in Pune, India. Puram means supreme in Sanskrit, and also creates an acronym for parallel machine. The Puram 8000 was a success for CDAC in delivering a gigaflops range parallel computer. It was launched in 1991. In 1993, the Puram 9000 series was released, which had a peak computing power of 5 flops. In 1998, the Puram 10000 series had a sustained performance of 38 flops on the Linpack benchmark. The AI supercomputer Airavat and Puram STI AI are currently the fastest supercomputers in India. Airavat has been ranked 75th in the world as of June 2023. Indian supercomputers in top 500 list. As of June 2023, there are 4 systems based in India on the top 500 supercomputer list. 75 Center for Development of Advanced Computing Airavat, PSAI 8.5 13.17. 131 Center for Development of Advanced Computing Puram, STAI 4.625.27. 169 Indian Institute of Tropical Meteorology Pratyush, CRE XC40, 3.764.01. 316 National Center for Medium Range Weather Forecasting Mihir, CRE XC40, 2.572.81. National Supercomputing Mission. The Ministry of Electronics and Information Technology in 2015 announced a National Supercomputing Mission, NSM, to install 73 indigenous supercomputers throughout the country by 2022. Objectives: the primary goal of the mission is to establish a cluster of geographically distributed high-performance computing centers connected by a high-speed network, forming the National Knowledge Network, NKN. It aims to enhance both capacity and capability in high-performance computing across academic and research institutions in India in their respective domains. Characteristics: infrastructure: it involves the deployment of high-performance computing centers, including 3 petascale supercomputers. Financial investment: the mission spans a 7-year program with a budget of $730 million, 4,500 rupees crores, indicating a significant financial commitment to advancing supercomputing capabilities in the country. Localization: it aims to produce all the components within India. Implementing agencies: Center for Development of Advanced Computing, CDAC, and the Indian Institute of Science. Achievements: Puram Shive, the first supercomputer of India under NSM, was installed in 2020 at IIT, BHU. Other installed supercomputers are Puram Prabha, IISC, Bangalore, Puram Utkarsh, CDAC, Bangalore, Puram Ananta, IIT, Gandhinagar, Puram Himalaya, IIT, Mundi, Puram STAI, CDAC, Pune, and Puram Vidya Series. Applications of supercomputers. Supercomputers are being used in multiple fields and have several applications such as weather forecasting and climate research. When the supercomputer is fed with data gathered via satellites, radars, and weather balloons, field experts become better informed on how atmospheric conditions affect us. They become better equipped to advise the public on weather-related topics. For example, the Derecho supercomputer is being used to explore the effects of solar geoengineering and how releasing aerosols influences rainfall patterns. Genome sequencing: it is a type of molecular modeling which scientists use to get a closer look at a virus DNA sequence that helps them diagnose diseases. The supercomputer can perform DNA sequencing in a few hours. For example, researchers at Stanford University scored the Guinness World Record title for the fastest genomic sequencing. Aviation engineering: supercomputing systems in aviation have been used to detect solar flares, predict turbulence and approximate aeroelasticity to build better aircraft. For example, Frontier has been recruited by GE Aerospace to test open fan engine architecture designed for the next generation of commercial aircraft that can reduce carbon dioxide emissions significantly. Space exploration: supercomputers can take the massive amounts of data collected by satellites, probes, robots and telescopes and use it to simulate outer space conditions Earthside. For example, at NASA, 8CAN is used to create high-resolution simulations in preparation for upcoming Artemis moon missions. Nuclear fusion research: they can create simulations to predict energy loss and optimize performance in plasma, used in the tokamak research. Example, Frontier and Summit for a project led by scientists at General Atomics, USA. Oil and gas exploration: they can be used to collect huge quantities of geophysical seismic data to aid in finding and developing oil reserves. Military and defense: supercomputing can allow the military to perform virtual testing of nuclear explosions and ballistic weapons. Smog prediction: many scientists and climatologists use supercomputers in the laboratory to predict fog and other pollution and smog levels in a particular region. Example, Tianhe-1A of China. Disadvantages of supercomputer. The following are a few disadvantages of the supercomputers. Physical size: supercomputers are physically large. Hence, they require lots of space. A supercomputer typically takes more than 1,000 square feet of area. Maintenance: for this purpose, special software and expertise are needed to detect failures and the computer's overall usage. Storage: to acquire the full capacity of a supercomputer, it should be equipped with enough storage space to accommodate all the produced data. Without sufficient storage space, the supercomputer simply cannot perform calculations. Heat release: a supercomputer is equipped with a large number of processors, all of which can generate a significant amount of heat during their operations. Due to this heat, most devices tend to get damaged easily. Power consumption: supercomputers typically consume large amounts of electricity. In general, a supercomputer needs around 4 megawatts (MW) of electricity. A computer is a sophisticated electronic device that processes data to perform tasks efficiently and accurately. It has become an indispensable tool in modern life, facilitating a wide range of activities from education and communication to scientific research and industrial operations. By executing instructions through software, computers automate processes, perform complex calculations, and manage large volumes of data. They serve as the backbone of technological innovation and digital transformation across the globe. Computer. A computer is an electronic device designed to accept data, process it according to specified instructions, and produce meaningful output. It performs computations at high speed, stores and retrieves information, and can operate autonomously or interactively with users. The functioning of a computer relies on both hardware and software components. Hardware comprises the physical elements of the system, such as the central processing unit, CPU, memory, RAM, storage devices, input/output devices, and communication interfaces. Software consists of the programs and applications that instruct the computer on how to perform specific tasks. Computers are integral to virtually every sector today, transforming industries such as healthcare, education, business, government, and entertainment. Their ability to automate repetitive tasks, handle large data sets, and support decision-making has made them essential for personal, professional, and scientific endeavors. Computers types. Computers are categorized based on their size, processing power, and intended use. The main types include supercomputers. These are extremely powerful machines capable of performing billions of calculations per second. They are primarily used for advanced scientific simulations, climate modeling, nuclear research, and space exploration. Mainframe computers, designed for large-scale data processing and simultaneous multi-user operations. Mainframes are commonly employed by banks, government agencies, and large corporations. Mini computers, mid-range computers. These are medium-sized systems used in specific sectors such as industrial automation or departmental data management. Personal computers, PCs. PCs include desktops, laptops, and all-in-one systems intended for individual use. They are suitable for tasks like word processing, internet browsing, and multimedia entertainment. Workstations, high-performance PCs tailored for professionals in graphic design, animation, engineering, and software development. Servers, computers that provide resources, data storage, and services to other computers on a network. They host websites, manage emails, and support enterprise applications. Embedded computers, specialized systems integrated into devices like smartphones, cars, appliances, and industrial machines, designed to perform dedicated functions. Computer components. Hardware refers to the tangible parts of a computer system. These components work together to process data and execute tasks. The major hardware elements include component description, motherboard, the main circuit board connecting all components, including the CPU, RAM, and expansion cards. Processor, CPU, acts as the brain of the computer, executing instructions and performing calculations. Memory, RAM, Temporary storage used to hold data and instructions currently in use. Case/chassis. Encloses and protects internal components. Power supply. Provides electrical power to all hardware components. Hard drive/SSD. Primary long-term storage for software, files, and operating systems. Floppy drive. Low-capacity removable storage device, now largely obsolete. CD-ROM/DVD-ROM. Optical drives for reading and storing high-capacity data. Keyboard. Input device used to enter data and commands. Mouse. Pointing device for navigation and interaction with the graphical user interface. Video card. Processes and displays graphics on the monitor. Monitor. Visual output device displaying text, images, and videos. Sound card. Generates audio output for music, games, and multimedia applications. Hardware is complemented by peripheral devices, which expand functionality and allow interaction with the system. Examples include printers, scanners, external storage drives, and networking devices. Software components. Software consists of programs and instructions that enable a computer to perform specific tasks. Without software, hardware remains non-functional. Major categories of software include application programs, programs designed for specific tasks such as word processing, spreadsheets, graphics, gaming, or music production. System utilities, tools that maintain and optimize computer performance, such as file management, disk repair, and antivirus software. System services, core programs that provide essential functionality, including database management, network services, and multimedia support. Operating system, OS, the primary interface between the user and hardware, managing resources and providing services like file management, security, and device control. User interface, UI, visual and interactive elements like windows, menus, buttons, and dialog boxes that facilitate user interaction with the system. Graphics engine, software that renders images and animations, enabling advanced visual display and multimedia applications. Computers' advantages. Computers have transformed the way humans live and work. Some key benefits include speed and efficiency, process large volumes of data rapidly, saving time and increasing productivity. Automation, reduce manual effort by automating repetitive tasks and minimizing errors. Storage and organization, store, organize, and retrieve vast amounts of data efficiently. Connectivity, enable global communication and information sharing through the Internet. Multitasking, perform multiple operations simultaneously, enhancing efficiency. Accuracy, execute tasks with precision, which is critical in fields like science, finance, and engineering. Learning and education, provide access to e-learning platforms, research tools, and educational resources. Entertainment, support gaming, multimedia, creative design, and streaming services. Innovation, drive advancements in artificial intelligence, healthcare, engineering, and scientific research. Computers' disadvantages. Despite their advantages, computers have several limitations. Health risks, prolonged use may lead to eye strain, repetitive strain injuries, and posture-related issues. Job displacement, automation and AI can replace certain manual or routine jobs. Dependency, over-reliance on computers may reduce critical thinking and problem-solving abilities. Privacy and security risks, vulnerable to hacking, identity theft, and data breaches. Environmental impact, manufacturing and disposal contribute to electronic waste. Addiction, excessive use, especially for gaming or social media, can affect personal and social life. Social isolation, overuse for virtual interactions may reduce face-to-face communication. Cost, high-quality computers and software can be expensive, limiting accessibility. Computer important terms. The future of computing involves continued innovation in hardware and software. Key trends include advanced processors, faster and energy-efficient CPUs to support complex computations. Quantum computing, exploiting quantum mechanics to solve problems beyond classical computers' reach. Artificial intelligence, AI embedding intelligence to automate decision-making and predictive analytics. Cloud computing, enhancing accessibility, storage, and collaboration across networks. Energy efficiency, developing eco-friendly components to reduce power consumption and environmental impact. Embedded systems, increasing integration in devices like smart appliances, automobiles, and industrial machinery. These advancements will enable computers to handle larger data sets, support smarter applications, and expand their impact across industries. Computer UPSC. Computers are versatile electronic systems that process, store, and retrieve data, supporting tasks across personal, professional, and scientific domains. They consist of essential hardware like CPUs, memory, storage devices, and input/output interfaces, combined with software programs that provide instructions and functionality. Computers are classified into supercomputers, mainframes, personal computers, workstations, servers, and embedded systems, each serving unique purposes. Their advantages include speed, accuracy, multitasking, and connectivity that have revolutionized industries, education, communication, and entertainment. However, challenges like health risks, job displacement, privacy issues, and environmental impact highlight the importance of responsible use. Looking ahead, innovations in AI, quantum computing, and energy-efficient designs will redefine the capabilities and applications of computers. By understanding their components, types, and applications, users can harness the full potential of computers, making them indispensable tools for innovation, productivity, and global connectivity.
Thank you for watching. Helps you in your UPSC journey. Don't forget to subscribe to our channel for more guidance and click the bell icon to never miss an update. Keep studying hard and good luck.